And welcome back to Mr. Gregorius Math. Today we're solving quadratics with factoring. So I have a few examples here that are going to go over a couple of different factoring types and also the correct way to show your solutions. Let's recall the steps though. Step 1, set one side equal to 0. Sometimes this will be done for you, like in our first two examples where we have the first side set to 0. In our last example, it's not quite done just yet. Step 2, we have to factor. This is the type of algebra that we'll be reviewing as we go through solving these. Step 3, we'll break into two problems. So remember, when we solve quadratics, we may have 0, 1, or 2 solutions. So some of these might have 2 solutions, some of them might have 1 solution, and some of them may have 0. And step 4, we solve each of those 2 problems and state our answer. Now sometimes those 2 problems will be the same, and we'll see what happens when that occurs. So we'll just take a look at the first example. Example, solve. So we have this quadratic that we need to solve, and it's already got one side set to 0, so step 1 is done. Step 2 is to factor. Now I recognize that I've got a difference of squares here because there's only 2 terms, the x squared and the 49, and both of these are perfect square numbers. So I remember from a boring math teacher that a difference of squares factors to conjugate pairs. So I'm going to set up my conjugate pairs right here. And in the first term, I'm going to have the square root of the first term of the quadratic. So that's x and x. Remember, conjugate pairs are exactly the same. They just alter the sign. So the middle signs are going to be different when we're done. And the last term of each pair is going to be the square root of 49, which is 7. So I've got 7 and 7. To make this a set of conjugates, I'll make one of them negative, one of them positive. It didn't matter which was which. And now I'm done factoring. So step 1, set one side to 0, that was done. Step 2, factor, that's done. Step 3, break it into 2 problems. So I have 2 factors, and these 2 factors are 2 problems. Each problem is what happens when the factor is equal to 0. Because I have something times something else equal to 0, that means my solutions are whenever these things are zeros. So I write it out by writing the factor and setting it equal to 0. That's one of the solutions here. The other solution is the other factor equal to 0. And now I've broken it into 2 problems. There's that problem and that problem. Lastly, I just have to solve and state. These are pretty easy linear problems to solve. I'm just going to add 7 to both sides for the first one to get that x equals 7 is one of my solutions. And I'm just going to subtract 7 from both sides of the other to get that x equals negative 7 is the other solution. So I have 2 possible solutions to this quadratic. The solutions are x equals 7 or x equals negative 7. And that's the whole process from a fairly simple type of factoring problem, the difference of squares. Well, let's take a look at example B. So example B is very similar, but it's not a difference of squares now. It also doesn't have nice square numbers, but it does have a coefficient of 1 in front of the x squared term. So that means this is going to be a simple type of trinomial. So simple trinomials factor by using our setup sound effects. Remember, it's so that way we actually have our place to put all of our values afterwards. Then we'll use the Gregorius sign principle. The first sign is the sign of the largest factor. So the largest factor I'm going to keep to the left is L and L, and the plus sign is going to go with the largest factor. The second sign is my decision. It says, hey, wait, if I'm positive, these 2 signs are the same. If I'm negative, these 2 signs are different. Well, since it's positive, these 2 signs are the same, and this one's positive, so that means this one's positive as well. And now I have to list my factors of 24. Let's go off to the side and do this. So I have 24 and 1, then 2 and 12, then 3 and 8, then 4 and 6. And I'm checking to see, is 24 plus 1 8? Nope. How about 12 and 2? 8? Nope. How about 8 and 3? Nope. How about 6 and 4? Nope. There's no other factors. So in actual fact, this one does not factor. Well, if it does not factor, then that might mean there's no solutions. And the reason why there's no solutions for this quadratic is because it actually looks a lot like this. So it goes down and back up, but it never actually crosses the x-axis here. So this is my quadratic, here's the x-axis. My solutions happen when it crosses, but this one, it doesn't cross. So we're not going to have any solutions for this particular one. So here we had two different solutions, and here we have no solutions. Now let's take a look at example 3. Now, or C, I suppose. Example C, we have to go back to our start and we say set one side equal to 0. Well, I don't have one side equal to 0, but I only have one term on the right, so I think I'm going to move it over. So I'm going to write this by subtracting 12x from both sides. Those will cancel, and I'll be left with 0 on the right-hand side. On the left-hand side, I'll be left with 4x squared minus 12x plus 9. And now I have to factor this, and I'm going, oh, ugly, it's not a simple trinomial. But I'm also really excited because 4 and 9 are both perfect squares. And that tells me this might be a perfect square trinomial. Remember, these are the ones that factor to a single trinomial squared, sorry, a single binomial squared. Now what we have to do is we have to just check and see whether or not it actually is going to factor this way. So we take the square root of 4x squared, which is 2x. We take the square root of 9, which is 3, and we say, hey, is 2x times 3 half of 12? And it is, because 2x times 3 is 6x, and 6x is half of 12. So this is going to work out to be a perfect square trinomial. So that means that 2x is going to be my first argument inside my binomial, and 3 is going to be my second argument inside my binomial. And the sign is always going to be that first sign. So this factors to 2x minus 3 squared equals 0. Now part 3 says break it into two problems, but I only see one factor here. That's because that factor is squared. So really what's happening is the problem from this is repeated twice. So I don't need to repeat it twice because I know I'm going to only have one solution because it's going to be the same solution both times I do it. So instead I'll just write the problem out once. So I need this factor to be equal to 0. To solve for this, I'm going to add 3 to both sides, which will get me 2x is equal to 3. And my very last step is I'm going to divide by 2. So that means the solution is x equals 3 over 2, or about 1.5. And if you were to draw this particular quadratic right here, what you would end up seeing is at 1.5, it would just touch the x-axis. So this one wouldn't go through, this one would just touch, and this one would go through and then back up. So its diagram would look something like this. You'd have minus 7 over here, plus 7 over here, and then it would go down and up. Of course, this is not drawn to scale, but you can see I have 2 solutions, 0 solutions, and 1 solution as my possible ways to solve a quadratic by factoring. That was solving quadratics by factoring with Mr. Gregorius Math. Don't forget to hit like, subscribe, ring that notification bell, and check the link in the comments for the merch store.